Okay, good morning, everybody. I hope you guys are doing well. Hopefully, that first section wasn't too difficult for you. So, let's begin to talk about section two on our review assignment. This section deals with polynomials. There's a whole bunch of properties there. I'm going to briefly go through them just so you kind of remember what each one of those properties means. So, the whole number exponents, what it means is if you have a repeated number multiplied by itself multiple times, you can simply write that number with an exponent. So for instance, if you had something like 2 times 2 times 2 times 2, you could rewrite that as 2 to the fourth. So that's what that first uh, property is explaining. The next property is pretty self-explanatory, and that property is it's the zero exponent property, which means anything to the zero power is 1. So you can see right here we have x to the 0 equals 1. You could have 5 to the 0 equals 1. You could have a million to the 0 power. It would still equal 1. The next one, property 3, is the negative exponents. The negative exponents tell us that if you have a power that is negative, you can rewrite that so the base and its power go to the bottom of a fraction, and then the power becomes positive. That property also works if you have a base and a negative power on the bottom of a fraction. It would move up top and no longer be in a fraction. So a couple examples of that. If you had 2 to the negative third power, you could rewrite that as 1 over 2 to the third. Another example would be if you had 1 over 4 to the negative 3 power, you can rewrite that as simply 4 to the third. So the negative exponent means the base and the power move either from the numerator down to the denominator or from the denominator up to the numerator. The important part of that is when it does move, it causes the exponent to become positive. The next one, property number 4, radicals. It's discussing about the nth root of something. So, in other words, if you had, let me think how I could do this. If I did 4 and then no, I don't want to do 4. Let's do 5. Let me erase this so it looks a little nicer. We're going to do 5, and then we're going to do the square root of 5. Okay, so the square root of 5 equals some number that we don't know. Actually, nope, I'm going to rewrite this again, and I apologize, kind of fumbling around here. We're going to do the square root of 4 like I was going to do, which is 2. Okay, one thing to keep in mind is when there's a square root here, this actually means there's a little 2 there as opposed to a cube root or a fourth root, right? So if they don't have anything written there, if the 2 is not there, we know it's there, it's just not written there. So what that means, and what this property is saying, is if you had the square root of 4 equals 2, you can rewrite that as 4 equals 2 and then to the second, since it was a square root, 2 to the second, like that. Sorry for that power. It's not very neat. Kind of ran out of room on my iPad. All right. The next one is the rational exponents. And the rational exponents is saying that if you had something like, I don't know, 5 to the 1/5, well, let's go with 1/4 power. So 5 to the 1/4 power, that can be rewritten as the fourth root of 5. And so you can have fourth roots, third roots, square roots would be a 2 there, which is what we just discussed. The last one is the rational exponents, and that one states if you had like 6 to the 2/3 power, this would turn into 6 to the second, and then that would be cube rooted. So the numerator of the power fraction becomes the power on the base, and the denominator becomes what type of root it is. It could be a square root, cube root, fourth root. All right, moving on to the next three properties. We have multiplying like bases. So an example of this is if I had x to the third times x to the fourth, that would mean it's x to the seventh. So you just add the powers if the bases are the same. That's pretty easy. Very similar to this. The first one was multiplying like bases. This is going to be dividing like bases. So this one would be if you had something like x to the seventh over x to the second, that would turn into x to the fifth power. So in this case, because the bases are the same, you subtract the exponents. And then the last one kind of deals with when you are and aren't allowed to, actually, when you are allowed to basically distribute the power. So these examples are showing you if you had like 2x squared like this, you can write 2 squared times x squared. That is correct. If you had 2 over x squared, you could write that as 2 squared x squared. And the last one shows you that if you have a power to a power, that you need to multiply. So if I had 2 to the third, and then all of that to the fourth, that would give me 2 to the 12th power. So you multiply 3 times 4. All right, so with that being said, we went over all the different properties that you might use. I'm going to go through examples A, B, and C. I am going to just rewrite them again, and so then those steps hopefully will make sense to you. So looking at the first one, you can see that we have 7a squared in parentheses, and then in the next set of parentheses, negative 2a to the negative fifth. So the first thing that you would want to do is, because you can see that it is multiplication between all of those items within that expression. It's 7 and then times a squared times negative 2 times a to the negative fifth. So we're going to reorder things so it's a little easier to understand. So we're going to start with the 7, and then we're going to put the negative 2 in parentheses, and then we're going to have a to the second, and then a to the negative fifth. So that's exactly what they did there. Now, the next thing that we would do is go ahead and multiply the 7 times negative 2, which turns into negative 14. And then we're going to use the property that says if the bases are the same, we can add their powers. So we have 2 plus negative 5. So that is going to turn into a to the negative third power. Now, the last thing that we're going to do is when you are simplifying these expressions, are not allowed to leave it as a negative exponent. So if you have an expression that has a negative exponent, you do need to move it to the other part of a fraction, so there is no negative exponent left, which means the a to the negative 3 is going to go down to the bottom. You do not move anything else except for the base and the power of the exponent. Now the negative 14 is going to stay put, so it's going to become negative 14 here, and then it's going to become a to the third on the bottom, and then that's going to be your final step. It is simplified. All right, moving on to part B. You can see inside parentheses we have negative 2 x to the negative 1 y squared, and then all of that is to the third power. So what we need to do for that is start by looking inside the parentheses and seeing if there is anything to simplify. In this case, there isn't, but you always want to check if there's any like terms to put together or any multiplication or anything. Remember, we're following PEMDAS. Looking inside the parentheses, there's nothing to do. Now we're going to go and we're going to deal with the exponent. And you can see that there's that 3 on the outside, and that 3 on the outside will distribute to everything inside. Now, a lot of times people will forget, but that 3 goes on to that negative 2, that 3 goes on to that negative 1, and that 3 goes on to the 2 right there as well. So sorry, that's a little sloppy, but you get the idea. So we're going to rewrite this as negative 2 to the third. Then we're going to have x to the negative 1 to the third. And then we're going to have y squared to the third. Now we can go ahead and multiply because these are powers to a power. Now you might say, what about the negative 2? Just turn negative 2 times 3 is negative 6. Well, we have to remember that that's not quite right. That negative 2 actually has an exponent on it, and it's to the first power. Kind of ran out of room there. So we actually need to multiply the powers. So 1 times 3 is 3. So this becomes negative 2 to the third. And then we have negative 1 times 3, which is x to the negative 3. And then lastly, we have 2 times 3, which is 6, y to the sixth. Now, I did just say in the last problem that if you ever have any negative exponents, you cannot leave your final answer with negative exponents. So note in the first part, this right here, the exponent is not negative. The base is negative. That does not change anything. You don't need to move it. You leave that there. But this one right here that I'm going to underline, that's x to the negative 3. That needs to go to the bottom. So we're going to leave the negative 2 to the third and the y to the sixth. And then on the bottom, we're going to write x to the third. And there's your final answer. If you want to multiply out negative 2 to the third, that is fine. Remember that up here, I'm going to go up here for a second. This should have had a set of parentheses around it, which means it would be negative 2 times negative 2, which is 4, times negative 2, which would then be negative 8. So if you want to multiply that out, that's fine. It's negative 8 y to the sixth x to the third, like that. There you go. All right, last one, part C. So on the numerator, we have 2ab to the fifth c squared over a to the third b and then c to the second. Always, again, look within the numerator, look within the denominator, make sure there's no simplification that could be done before you start trying to move things around. There is really nothing to do too much. So we're going to get our fraction written. The 2 is going to stay on top, and then we're going to go through each like term. So on the top, we have a, which is a to the first, and on the bottom, we have a to the third. So one of our previous rules for quotients or division was that if we're dividing two of the same bases, you subtract their powers. So 1 minus 3 is actually negative 2. So we're going to write a to the negative 2. And now looking at b, we have b to the fifth on top and b to the first on the bottom. And so again, we're going to subtract. 5 minus 1 becomes 4. So we have b to the fourth. And then just always put them up top, and then you can figure out if they have to move. The top is c to the second. The bottom is c to the second. There's a couple ways you can think about this. The first way to think is c squared is c squared. They're both the same. So anything divided by itself is 1. So this would actually just cancel out. The other way you could think about that is you are subtracting their powers. So it would be c to the 2 minus 2. 2 minus 2 is 0. Anything to the 0 power, c to the 0, is going to be 1. So it just turns into 1. So right now you can see the expression we have. If you don't have anything on the bottom, you can put a 1, or same for the top. If there's nothing up there, just put a 1. You do see that it's a to the negative 2 is on top. We are not allowed to leave our final answers with a negative exponent. So we're going to put the 2 and then the b to the fourth here, and then a to the negative 2. I'm sorry, not negative 2. A to the second. A to the second will be on the bottom. And there's your final answer. All right, guys, hopefully that made sense to you. Hope you're doing well, and I will talk to you soon. Bye.